So, here's a question in front of you. Find such a pair of natural numbers which when added gives 20 and when multiplied gives the highest product possible. So, we'll start with a general proof for this kind of questions. Now, let us assume that two natural numbers add up to x, that is something plus something gives x. So, we can write it as x is equals to something plus something. Now, any two natural numbers which add up to x can be written in the form x by 2 plus z plus x by 2 minus z, which gives x. Here z is some integer. Now x by 2 and x by 2 adds up to x and z and minus z cancels each other. Now let's take an example to understand the equation better. In the question we are provided that two natural numbers add up to 20. Therefore let x is equals to 20 and the two numbers be 11 and 9. Now x by 2 is 10, therefore 11 is equals to 10 plus 1 and 9 is equals to 10 minus 1, which gives 20. Here z can be equated to 1 and x by 2 can be equated to 10. Now let's get back to the original equation. If we multiply these two terms, we get x by 2 plus z times x by 2 minus z. Now we can simplify the equation by the identity a plus b times a minus b, which gives a square minus b square. Therefore we get x square upon 4 minus z square. Now we want the highest value for this term, but we cannot change the value of x, but we can change the value of z. So we'll look for the value of z which will provide the highest value for this term. Now we can clearly see that when z is equals to 0, we get the highest value for this term. So we'll put this value of z in this equation. So we get x by 2 plus 0 times x by 2 minus 0. So we get x by 2 times x by 2. And at last we get x square by 4. Now if we get back to the original problem, we get our answer as 10 and 10. Therefore the two numbers are 10 and 10 and the highest product possible is 100.